The column space of a matrix A, denoted col A, is the span of the columns of A. The null space of a matrix, denoted null A, is the set of all vectors x so that AX equals 0. Both the column space and null space are subspaces of wherever they live. I'm sure you'll have to prove this eventually. Finally, a basis of a subspace H is a linearly independent set that spans H. Bases are incredibly important, and we'll discuss them in far more detail. For now, think about them as the minimal amount of information you need to construct a space. For example, 1, 0, 0, 1 is a basis of R2, but so is 1, 2, minus 1, 2. But 1, 0, 0, 1, 1, 2 is not a basis. This vector is a linear combination of the others, so it's not a minimal amount of information. And I could have picked any one of these three vectors to have circled. Let's do an example finding the column space and null space of a matrix. Let A be this 3 by 5 matrix. Find a basis for col A and null A. Like every problem we do that starts with a matrix, reduce it. First, the column space. See the two pivot columns of this matrix? The two original columns corresponding to these are the basis. So the basis is minus 3, 1, 2, minus 1, 2, 5, and that's it. That's how you find the column space of a matrix. Don't try to make it more difficult than it is. Just be sure you go back to the original matrix to get the columns. To find null A, you need to solve AX equals 0. Well, we've already reduced the matrix, so we can write the equations. Write the vector x, plug in the pivots, separate, and finally the basis is these three vectors. We've done innumerable examples like this. If it's at all confusing, go back and review. We'll be doing it quite a bit in the future as well. Notice, each vector in the column space has 3 coordinates, so it lives in R3. However, there are 2 basis vectors, so it looks like R2. In other words, the column space is a plane sitting inside 3-dimensional space. The null space lives in R5, but it looks like R3. I'm not sure how to describe what this looks like, but I'm guessing it's something like this.